Hi folks, welcome back to Math with Captain Rod. The purpose of this video is to demonstrate how to differentiate functions that have logarithm or natural logarithmic pieces in them. So what we're looking at here is a function y equals x ln x over 1 plus ln x, and we're going to talk about how to differentiate this function. So when we differentiate, you always want to kind of look at the big picture, the whole thing. And what we're looking at here is we've got a quotient, and in the numerator of the quotient we have a product. So we're going to be applying both the product rule and quotient rule to this problem. So first line of differentiation here, treating this like a quotient, we're going to have to differentiate the top times the bottom. However, when we differentiate the top, we're going to have to apply the product rule. So first line is going to look something like this. Derivative of the top. Now, when we differentiate the top, again, we have to apply the product rule. So derivative of the first is going to be a 1 times the second function, ln x, plus the derivative of the second function, ln x, and the logarithmic function has a derivative of 1 over x, times the first. So there in parentheses, there's the derivative of the top of that thing. Then it needs to be multiplied by the bottom. 1 plus ln x. All right, so this line represents the derivative of the top times the bottom. Minus. Now we need to differentiate the bottom and then multiply by the top. So when we differentiate to the bottom of this thing, 1 has a derivative of 0. ln x has a derivative of 1 over x. So there's our derivative of the bottom times the top. And then that's going to be all over the bottom of this thing squared. So that's all going to be over 1 plus ln x, the quantity squared. So there's example 1 of differentiating a function that's got logarithms and quotient rules and all sorts of cool stuff. I'm not going to bother simplifying this because that's just cosmetic, and this video is just about how to differentiate these functions. So what I'm going to do here is I'm going to just pause this for a moment and write out another example. Alright folks, so I'm back here and we're going to go through example number 2 of differentiation of functions that have logarithms or natural logarithms involved. So again, it always pays to kind of take some time and overview what we're looking at. So we got multiple things going on. We've got a product inside of these parentheses. So we know we're going to be applying the product rule. In addition to that, this thing inside the parentheses is being squared. So we've got a composition of functions, right? Something squared. So we're going to be applying the chain rule as well. All right, so when we differentiate this, first thing I'm going to do here is differentiate the outside function, which is the square part. So when we differentiate the square part, we're going to get 2 times x squared ln x to the first power. So the squared is now differentiated. Then we're going to move in now and differentiate the inside part of this, and that's where we're going to have to apply the product rule. So parentheses, let's see, derivative of the first term times the second, plus the derivative of the second. Now the derivative of ln x is 1 over x times the first. And the differentiation part of this problem is done. I'll go ahead and maybe write one more line, clean it up a little bit. So this first term we can write as, how about 2x squared ln x inside here. Let's just write that 2x ln x plus x, since x squared over x reduces to x. And that's far enough on this problem. Again, the purpose of this video, this demonstration here, is just to demonstrate how to differentiate functions involving logarithmic functions. So hope this video helps demonstrate those concepts. Have a great day.